So we are in 9.3, I believe. We did finish this stuff right here, right? That was all the blah blah, but we finished this stuff. Okay, so what we really have been doing is just talking, and finally we're going to be doing. I feel like we did some of this. Did we do any of that? No, not at all. Yeah, we have not done this. Okay, so there's a lot more blah 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 here. I don't really care about that. It doesn't really matter to us. This is the actual stuff. Notice that it says p-value. That's the math. That's the math, and you can see it here. I got my bag in the way today. You can see that we have that p down here. That's what we're going to start calculating really quick, like, okay? I'm going to use GeoGebra to do it all from here on out, okay? It's GeoGebra time, finally, and that's a good thing for us. Okay, but the very first question says, find the p-value for a left-tail test where you got this is my z-score and alpha's that much, go. Now, traditionally what I would do is pull up the real bell curve and start working on that. It's very simple to do that. I honestly feel like I should, but I want to see if I can like cheat the system. Or like already? Yeah, already. What if I do this left tail test and I'm going to do this 0. It's not working. Here we go. 0. Standard deviation, let's do a 1. And n, I don't know, 30. Sounds great. Z. No, it's not going to tell me. Okay, never mind. This is not going to help us. See, look, they're like confused. All right. So what's really going on here? How are we going to calculate this stuff? What's going on is that we have a left tail test. So it looks like this, doesn't it? And they're saying that Z right here is negative 1.55. Okay. So far, so good? Okay. So then what is this probability over here? What is the area? How much do we have on that side? So let's make the picture look like that. I'm going to do this side. And change this to negative 1.55. Does that about look like the same thing? Mine looks worse, of course. But you get the picture, right? And what do they have? A little tiny number. 0.0606. That's my answer. There's definitely a way to do it in the other GeoGebra settings. We won't be doing this very often. But I think when it's so simple, I would just recommend to go simple. Is that cool? Okay, easy enough. All right, awesome. So they're wanting to do the conclusion stuff here. And I don't remember how we did that last time. It's been a while. H naught, H sub A, blah, 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 blah. And then I'd say, oh, look at this guy. It's a left tail test. And it looks like that. Yes? Y'all remember all that kind of stuff. Okay, cool. And this was the claim, always in the bottom. Yeah. But then after all this, we had P and we had alpha. And so my P is the 0.0606. My alpha is 0.05. And I asked you, which one's the bigger one? Chomp, chomp the bigger one. And which one is? P. P is bigger one. So, all right, P is greater than alpha. And if you go back up to that decision rule stuff, I'm just going to remind you, that's a fail to reject. H naught. Like I'm just copying down whenever I had this is the answer for that. What does fail to reject mean again? Accept. Very good. Accept H naught. So, okay, which one would make sense then? A, B, C, or D? B. Yep. You can see that we got P is greater than alpha, fail to reject. Cool. And that's it. Good. It's pretty straightforward. But again, all this stuff before, we're going to be doing it again soon. And then afterwards, we have a little bit more to say. But the p-value should be pretty much decided for us very soon. Like, any questions on, well, the simplicity, I guess? Okay, so let's do it again. Two tails. So what does that look like? It looks like there's two different tails to it. So I want to click and see if I can do that. So it's not this one, it's not that one. Is it going to be one of these? Here, let's like see if I can get a picture here. Okay, so not that. It's like the inverse of that, isn't it? If I click this guy. Ha! Good. Okay, cool. And they say we got z is equal to negative 1.9 2. So 1.92. But I have two numbers that I have to put in here. Can you guess what I would put on this side? Just take a guess. 1.92. It's got to be symmetric, right? Exactly. Now I think I need to stretch this out because I'm not seeing my answer. There we go. Cool. It should be symmetric. And so if I'm looking for both, the p-value here is now 0.0549. There you go. Awesome. And again, I have my p, I have my alpha, and I'm comparing them. Chomp chomp the bigger one. Which one? Yep, p is greater than alpha. And therefore I'm going to fail to reject. Very good. Awesome. So A, B, C, or D? B again. Yep. Two of these are always wrong, by the way. So this will never happen, and this will never happen. So it's really just A or B. You know what I mean? Well, I guess B or D in this case, but you get the idea. It's binomial. Oh, that's going back some. Good. Overall, pretty straightforward, right here. Okay, we're good. I don't think I'm going to be using this picture anymore because we're going to just have GeoGebra do it all for us automatically. Apply for 3D1, here we go. So, sales associate would like to test the claim. Ooh, that the average number of sales made by a sales associate is less than 600. Pause. We can already start setting up this problem, okay? So here we go. They're doing everything we did last time, H naught, H sub A, and it says the average, so I'm going to use a what right here in the front. Do you remember? You know what's called? The mu. Mu. I'm going to write that out. Mu. It sounds like mew. I guess that looks more like meow, but whatever. Anyways, mu. Like a kitty. And so then I have the 600. And the claim is always on the bottom. And the claim this time was that it was less than. So up top, I'm going to have a greater than or equal to, primarily the equal to, right? Because that's how GeoGebra is going to do it. They have that straight equals. I guess you can't really change it, but I'm teaching you the proper way here. Looking at, I want to erase what I just did there. Okay, there we go. Okay, looking at this guy, what kind of tail test do I have? Left tail test, very good. Quick picture, it looks something kind of like this. So that's what I'm looking at. Okay, I got all of that from reading one sentence. Okay, all of that was, I didn't even read the rest of this of the statement here. I just said one sentence, boom, and we got all this already. So that's pretty neat. That's pretty cool. Okay, this table and bag are like annoying me. Hold on. You can't see this online, but I have like a lot of stuff in the Appleton, don't fall. He's my new friend. And look, Spooky has got the pox. Yeah, it's sad. And so someone actually left him a pill to take. but I'm giving it to Spuddy because he's looking pretty bad too. It's a Tylenol apparently. It was just a random pill sitting on my desk. I was like, who gave him a pill? It was a Tylenol. We had to go look it up though. Moving on. I know that's kind of weird. Okay, so I got all this stuff. Let's keep reading. To test this claim, the sales associate collects data from 40 folks, and they found a mean of this much. We already know a standard deviation of that much. And notice it says population. That's what separates this test versus another one. So let me show you. We got the Z test has a little sigma, but if I go to T, it has an S. That's the only difference between these two. Sigma, population, T, S, sample. Got me? That's the only difference between the two different homework sections later, okay? Very, very similar stuff. Assume population normally distributed. We got alphas this much. Here we go. All right, cool. Let's do this thing. I'm going to put it all in. So what do I put in this box up here? Just take a guess. It says 600. Yeah, that's the null hypothesis. Null is H naught, little zero down there, you know. Which one should I click here? The less than is already there. Yeah, good, good. The mean, what do I put in this box? 575. My standard deviation. Awesome, awesome. N, N, 40. Awesome. There we go. We got all our numbers. And you can see blah, 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 p-value. P-value. That's important for us. Now, I'm going to show you about this test statistic now. I think I've kind of skirted around doing it for a while. I haven't told you about it, but this p-value is very important. So let's do the p and then the alpha. So I got 0.187, negative 2. No. Sorry. We're going to talk about that later. My bad. What's my alpha? Alpha? Right? Yeah, that guy. Yep. They give it to me. Alpha's basically what I'm testing against. Generally, if they don't say something, I would just say 5%, because it's like a nice cutoff line. 5% was the unusual, not unusual kind of stuff. So what I have is this side is 18, and this side is 25. Chomp chomp the bigger one. Which one would it be? Alpha for sure. So P is less than or equal to alpha. That makes me want to reject. Yes, very good. Yep. Reject H naught. Yep. Very good. And this is the fun part for me. I get to change colors now. So reject H naught. I want to show you what that looks like. H naught, rejected. No good. Okay. But this claim is good. Good claim. And we get the smileys, and I'm going to start doing flowers again. Let's do a star. That looks so cool, right? We like the claim. Claim is good, right? Good claim. So I want to put that into other language here. So I'm going to say yes or no support for the claim. And you're going to say yes, support that claim. Okay? So that's all of the verbiage here. Oh, that was it? So, like, what do we do? What's the answer? That's the answer. Right? If you remember back on the homework, what we were doing, they ask multiple parts. They'll say, do we support, reject, not reject? You know what I mean? We go through all that big list of stuff. That's how it works. Okay, cool. Good? Awesome. Okay. So yeah, I guess what we support, yes, support that. It's less than 600 sales. Okay, awesome. Oh, I wanted to do the test statistic thing. Okay, so I'm going to use a different color because this is it's not off topic. It's just not a primary thing to get all these answers. But this is a left tail test, and we're already saying it's reject H naught, which is kind of nice. What I'd rather do is, okay, yeah, let me do this. Okay, so this is a brand new topic. Kind of just switch gears with me for just a minute. We do not need to do this every time, but I do want to show you. This zone is called the rejection region. Rejection region. Okay, and this zone is my alpha equals 0.025. Okay, that's 2.5%, and I can show you what that looks like over here. Like I could just draw a picture here. So yeah, it looks like that. There's my picture, okay? That's called the rejection region. Now, I am going to come in with my result. And my result back from over here is negative 2.08, okay? So I want to know, where is this cutoff line here? And for this guy, it changed. There we go. Is 1.96. So in the green, hold on, in the green, this is negative 1.96. That's my z-score. This is the cutoff line for the rejection region or not. Okay? So far, so good. Are y'all okay with that? Now I go back to my numbers. I did my numbers, blah, 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 and I found negative 2.08. Okay, that's my z-score. if I put this on a number line, like this being 0 right here, right? That's 0. My negative 2.08 would be somewhere right there. Yeah, negative 2.08. Now I'm going to ask my red right here, is that inside of the rejection region? Yes. Like he's in this bad zone, rejection region. You know, it's a. I'm trying to think of like something like the Badlands. You know, it's all like drought and the trees are all dead, and it's like, nah. It's like nobody wants to go there. But I fell into that zone somehow, right? And so that's when you reject H naught, because we're in the rejection region. Yeah. So like this, there's a rejection region, but my result was somewhere over here. Go away. How do you go away? Go no. Like right when I'm okay. Look, scroll. Okay, fine. I'll beat it that way. It's seriously not going away. Anyways, if let's just say I had my value right here, would I be in this rejection region? No. It would be in the happy zone. There's like sunlight over here. Everyone's happy and they're like playing. Yay. So that would be fail to reject. That would be accepting. That would be good. You know what I mean? So that's kind of idea. Where does my cutoff line happen? Is it this way of the rejection region or that way of the rejection region? Okay. So do you need to do that every time? No. I think it's way easier to do a and you can now decide, is that strong or is that not strong enough, right? I'm giving you 1.8. Is that the numbers that we have? Oh yeah, I give you 1.87. To me, I can say, wow, that's pretty low. It's definitely less than 5. I could even go say it's less than this 2.5, right? But it's not less than know already. It's a probability, it's a percentage. We already know this very well. Cool? So that's why, okay. Blah, 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 blah. P-values are awesome. Moving on. So, I know. Okay, there. I fixed it. I just have to click on it. Okay. Next problem. Orthopedic surgeon would like to test the claim that the average heal time is greater than 19. Hold up. Here we go. H naught. HA. So H naught. What would I put here? Mu. And, oh, well, yes, I guess you're already right. Thank you. Let's do the 19, the mu, and the 19. And so, yeah, my claim down here, is right here. What would I put in this space? Greater than, so therefore, you already said it. Less than or equal to, yeah. Does it make sense? I'm working backwards on that because you always start with the claim. With this guy, what kind of tail test am I going to have? Have you been noticing that I point in the direction that it is? I've been doing that because I've been silly. Because like, see how the arrows are pointed to the right? So it's like, you know, well that's your left. You get my okay, cool. Yeah, someone mentioned that one semester, like it's pointed in the way. Yeah, exactly. That's true. And we got all of that just from the first sentence. So then, to test this claim, surgeon collects samples from 30 people and records a mean of this. Population standard deviation, that's again in this section, is 2.4, 1%, and here we go. So I need to put something up here. What do I put in this box? 19. A, B, or C? B, greater than. The mean that I found was, bam, standard deviation. And then my N was 30, and there we go. And so you can see I have a p-value, 0.4097 versus they have 0.01. This is very strange, right? This is very weird. Okay. So I need to chomp the bigger one. P greater than alpha. So therefore I, yep, do not reject, fail to reject. Again, I like to say except. I know they won't have that, but it helps me to understand what that means. Okay. Cool. So now I get to actually do that. I'm going to fail to reject H naught. I'm going to accept H naught. And that looks like this. Check marks, smiley faces. I'm going to get better at this flower thing, okay? It's like a 4-leaf clover now. Rainbows. Yay. Rainbow should be like this, right? Yeah, that looks like a rainbow. Or a big arch. And now it looks like the golden arches. So there you go. Hamburgers. Yay. This claim is bad. Bad claim. Bad claim. So we have options, yes or no, support for the claim, and you would say no support for that claim. Bad claim. Bad. Bad claim. There you go. You did it. Yay. I know. All right. Should we clap every time? Here, let me do some confetti. I don't know. Do I have some confetti? Here, I'll throw some water around. You're like, oh, I don't want to get wet. Anyways, good? Okay. We do this like a bazillion times, but it's fun that way, okay? Any questions? Comments or concerns? Thoughts? Okay. I thought this was a pretty interesting thing. My p-value is super big. And if you notice, it says greater than 19, and it's like 19.1. And like, that's not very much difference. One thing that I found that was funny, sometimes this happens, it says claim is greater than 19, and they got like 18. Like, you know what I mean? It's like automatically like, well, that's not going to help. You said it would be greater than 19, and you got 18. CEO wants to determine if the average time for employees respond to emails during the day has changed. So this is an interesting keyword here. I think that it means two-tailed tests because it's not saying greater or less than, it's just change. Okay, so CEO randomly selected this many, asked how long, okay, historically, good, assume, oh, here. It was previous this guy. I think that's going to be a key here in just a second. Assume this, use a calculator. Okay. So I didn't see anything about greater or lesser. So the mean, right, the average, so we're going to have a mu. And I'm going to put the whoa, dyslexia, 155. But what would be the claim then? Not equal to. They don't say greater than or less than. They just say different, basically, has changed. If you've seen it before, they've said the word different. So that's a something we can use. So then, therefore, I put up here plain equals. Like there's no, like that's the opposite, I guess, right? This is my claim, always down there. And what kind of tail test? Two-tailed test. Again, in case somebody asks, which you have seen, they do ask. It looks something like that. Okay. Time to put it all in here. So I got my 155, and it's a not equal to. But what's my mean that I found? Yeah. And if you look carefully, do you see how it says the sample mean? And that's how I know it's this guy here. Rather than this mean here was the population previous, we already knew that kind of stuff. That was the null hypothesis stuff. Standard deviation of, bam. And we surveyed 10, ain't no good, is it? So there is a slight interesting kind of site here. Okay, 10 is not very good. But you see this phrase here, assume the population is normally to this, okay, the population standard deviation needs, okay, and then the distribution, okay, yeah. Assume this, and that, okay. But that normally distributed thing is important. If you don't have it, then it just doesn't work. You actually just get to give up and just go home. I guess. Kind of weird, but you know, that's what it is. Back to the blue. Okay, so I have my P, I have my alpha. My P ended up being 14, but my alpha was only 5, which is a good standard number. So, which one's bigger? P is greater than alpha, therefore I accept, fail to reject. Very good, very good. Yes, that's H naught. Accept H naught. Okay, awesome. So I'm going to go and accept H naught. Oh, yes, we like H naught. We're happy there. I'm going to make a big, big smiley. Let's put a tongue on him. Yeah, tongues. It's not rude. It's fun. Okay, so, but ooh, bad claim, bad. I'm gonna do like frowny. No, you know what? Let's make him angry. Bad claim. So I have options: yes or no support for the claim. You would say no support for that claim. He says that it's changed. He asked 10 people. He didn't get anything close. I mean, he said that it was 155 and he got 157. You're only asking 10 people. I mean, it's not really changing much. You know what I mean? So, okay. It could happen. That's not unusual if that were to happen. Not unusual. Okay. How many of these are we going to do, Chad? I don't know. However many there are. GeoGebra notes. I don't know what you want to put here. This is the Z test of a mean. I mean, I don't know. That's what we're doing. Whatever you want to put there. Okay. Decision rule based on rejection region. Oh, we just talked about this. See, I was thinking it was going to come up eventually. It's like as if I teach this class once in a while. So we already know again the left tail, right tail, two tail, and so these right here are again the rejection regions. Rejection region, and that's like all of these guys too. Anything in the blue. So if your value falls into a rejection region, no good, fail, you know, or I'm just guessing just reject. Rejection region, you reject, and then we're done. All right, cool. So blah 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 blah. I don't even understand what they're going with right here, but we're just gonna ignore because we already done this a few times. Blah 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 blah. 30. No. I mean, really, that is kind of important, but you know. Find the critical value in the rejection region for a left tail test with this much. Left tail test looks like this. That's easy enough. Alpha means the area. Oops. Yeah, no, that does not look like an alpha anymore. It just looks like a fish, just a plain fish. That's an alpha. Okay. So alpha is, again, that's an A, stands for area. The area, the probability is that 10%. What they're looking for is, what is the z-score here? Where's that cutoff line? Where can I now say, hey, this is cool and that's not cool? So back to the picture. I want this picture to look like that picture. So 10%. Better now, better. And so here's my answer down there. And we're done. Negative 1.28. That's what they want. There's your answer. That's the cutoff line. That's a line in the sand dividing between the night and the day. The Badlands with the trees that are all like, and then you got, you know, the happy plains and everyone's running around, you know, and having fun, sunlight and stuff, flowers. Yeah. There you go. Two tail. Okay, so I want that picture. And they're saying that the area, and I mean the total area, I'm going to write total area, is 8%. Okay. Now I know we can go and say, oh, that's 4 and 4 and all that. Yeah, I get that. Okay. Let's go and just do some picture action. So I want to see, can I make this thing work? Oh, okay. Let me like prove a point to you here right quick. So like I got something like this. That's a two-tailed test, yeah. But I'm looking to find this right here to be 8%. Just folks at home know what I'm doing. It's not working, right? So how do I do that, right? How do I actually put the number in? Well, and how they're kind of explaining it up there, that makes this 4% and 4%, yes? So what if I just like did the 4%, basically? So if I went just one side and I change it to 4%, so then this was at negative 1.75. So this side over here must then be 1.75 exactly, because they're symmetric. So that's another way to do it. That's your answers, by the way. They're like, hey, where's the cutoff lines? There you go. We found them. Oh, how nice of them. So some of these are more common than others. Let me remind you here. So this was for 95% confidence. That's the confidence interval. This was for 98. This is 99. This was 90. And this is 80. But blah, 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 these are the confidence intervals. If you remember what confidence intervals do, it's something that's like that, right? What does that remind you of? A two-tailed test. And so these values they can be used for one-tailed tests as well. But the two-tailed test is what we remember the confidence intervals with, right? Because that's when we saw these last. Okay. So then what are these values that they're giving us here? I mean, haven't you ever noticed that they give us some weird numbers here that I never really use? But now we actually can use them, because what these numbers are for the one-tailed tests. So like if you have a 5% on one side, then you could just use this number, right? So that's a one-tailed test. It's like if I had a 5% or something, I'd say, oh, 5%, boom, we're done. So that's another style of doing that. Again, though, we're not using that hardly ever. The main reason they just wanted to remind you, like, hey, look, we've done that before. Cool? Okay. CEO of a company claims that the mean workday is less than 8.5 hours. Pause. Let's set this thing up. So mean is a mu, 8.5 here and there. What do I put here in H sub A? Less than, because that's my claim. So therefore up here I put greater or equal to. Very good. What tail test is this? Perfect. And again, if somebody asks, looks something like that. Awesome. All of that from just one sentence. We're getting to professionals at this thing, right? Yeah. Okay. Well, back to this thing. So a random sample of 25 folks had a mean of 8.2. I guess my original was the 8.5. Less than. And my standard deviation, 0.5. Wow. I think I put everything in right. Okay. Notice the amount of zeros here. Which one's actually bigger? Yeah, the alpha's bigger. So P less than or equal to alpha is a reject. Very good. And like that's basically it. We're just reject. So get a different color. So I'm going to reject H naught, but then that means I accept the claim. Claim is good. We like the claim. Happy days. So again, yes, no, support for the claim. And you would say, yes, support for the claim. I can't even write support. Yes, support for the claim. Cool. Ah, those kids out there, they're just having fun. Anyways, yeah. So if you go back, it says the CEO claims that it's less than this much, and he found 8.2. See you later. And so it is less than, but by how much? And normally he was saying, well, standard deviation of only half an hour. Well, we're pushing the limits of that already, and we asked 25 people. So I guess it's like really weird that out of 25 people, we got 8.2 was the average, rather than what we thought was 8.5 was the average. I mean, I guess the numbers are the numbers, right? Cool? Okay. Let's just say that I'm going to do rejection region on this. That way we can test this. You know, we can kind of play around with this a little bit. So that means that this alpha here is 1%. That's my zone right there. But the cutoff line would be then right here. Again, that's the one-tail test numbers, are these guys. So that's going to be a negative 2.326. So that's my cutoff line. What was the z-score that I got? Negative 3.00. Like, however weird that is. Negative 3.00. Definitely, you know, dark and scary. So yeah, reject H naught. Rejection region, reject. And then we just proceed and do the rest of the stuff. Basically, is changing this guy. I'm basically just saying, we don't need this. We'll go directly here. Okay. Well, actually, we don't even need to do that. We'll go like directly there. But the point is I still rather just do p-value because it's almost easier. Otherwise, for this, I actually have to go look it up every time, or I have to go and use this thing to go and find it, and it just gets annoying. P-value, you look at it, you get it, you're done. It's so fast. That's why I continue to use it every time. Cool? But I have to show it because that's what the homework will be about occasionally. Okay, let's just look ahead. How many more do we have, Chad? Because you know what I mean? That's the last one. Okay, cool. I was getting a little nervous because, you know, it's getting a little long there. Not that we got plenty of time here, guys. Plenty of time. You know what? Let's just stay for another 30 more minutes. Wait, you're like, no way. We can't stay for 30 minutes. I do want to go into the next section again. Just we'll see though. I don't want to go too far, but not enough. We'll explain. Okay, so U.S. Department of Agriculture says the mean cost of raising a child from birth to age 2. Like that's it? Gosh, man, they don't eat that much, do they? $14,000. Let me tell you, medical costs. Okay. Besides that, I think they don't eat that much. Okay, not by that time. My 2-year-old doesn't. Moving on. So, and you think that the average is different. Okay. So you're not going to say it's above or below. You're just, not biased. I'm just saying it's different. And so the average, so they're going to use the mean, 13,960. What would I put here in the bottom? Not equal to. My claim is not that it's greater or lesser. It's just different. So not equal to. Therefore, up here I put a. And this is a. I know, right? It's like very repetitive. That's why it's the last one. Not of the day. No. Don't get that in the brain. I do want to keep going a little bit more because it's the same stuff for the next section. So I think it's fresh on our brains. Okay, cool. I think that's great. Okay, so we collect a random sample of families, and we got this is this much. So, I mean, to me, those are very similar, okay? We had a sample of 500, though. That's a lot. You know, these other guys we've been doing like 10 or like 20, 30 is really what we should be doing. Now I got 500. That's awesome. So it really might mean something now. 13, 7, 25. Oh, I put a lot of slashies in there. Okay. Standard deviation. Oh, that's nice. And then 500. Okay. And so I got my p-value of 0.025. And they happen to have it as 1% this time. Ah, so small. So you can see that's pretty good. 2.5%. But they wanted it super, super, super sure. They wanted a 1%. So which one's bigger? P is still bigger than alpha. Therefore, I'm going to fail to reject, which actually means accept. Yep, very good. I'm going to accept H naught. I guess that's fine. We're going to reject this, or not reject the claim. We're just saying bad claim, and therefore we have yes or no support for the claim. And we would say no support for the claim. There it is. But I gotta say, if I was running this kind of study and I got a p-value of 0.025, I don't care kind of what they would say. Oh, we want to be super sure, blah, blah, blah. I would say, boss, let's just tone it down a notch. All right. I think we could probably say something about this. And at least if we were going to do some kind of report, let's say to the government or something, we could say, yeah, it didn't meet the standards that were set before us, but it was pretty darn close. Okay, so we can at least say a little bit there. Watch this funny little thing though. What if I had changed it to the direction in which it went? So notice that I have a mean that's less. What if I didn't say different? What if I had said originally less? See how the number changed all of a sudden? You see my p-value? I know that it's still technically not meeting that criteria, but whoa, it's close. And it's than less than or something, changes the whole p-value, yeah, and then we would have a different conclusion just because of that. So I don't know. It's just something to think about. I know that y'all aren't going to make all these reports. I know, but maybe you will, and you just don't know it yet. I didn't know I would, and now I don't. But I do something similar once in a while with the boss. So, anyways, cool. Okay. Yeah, one time we were doing a comparisons test on the pass-fail rates of our algebra to pre-cal and pre-cal to calculus folks, and dropout rates and all that kind of stuff. And we used p-values to prove that this or that was happening. It was pretty interesting. So like this, we do this math even upstairs. I'm trying to say it's fun. It's fun. Okay, keep going. So this is the only difference here on this is that sigma's not known. And so we're going to change from Z to T. Wow. I mean, that's literally the only change that we're doing here. Now, they do talk about this degrees of freedom stuff, which is nice for them. But notice we don't have to put that in. They give it to us anyways. The bigger point is that I don't think there's any difference, really. I'm not worried about this at all. No difference. So I'm going to keep cruising. Yeah, great job. Let's just do the math. Okay. So we have a left tail test. Alpha's this, N is that. Go. All right, now I'm scared. I thought it'd be easy, Chad. Well, I don't want to use tables. I want to show you how to do it regardless of the table, okay? Because tables are not always there for us. So if I needed to find degrees of freedom, which I'm guessing I have me do, what would be my degrees of freedom? 17, yeah, it's always one less. And they're going to want you to put that in to GeoGebra here in a second. So they're asking for where's that cutoff line again? And we've done this a whole lot. There's a left tail test. Over here is the 0.005. Yep. And so they're saying, what is this cutoff line? Where's the cutoff line there for that? And I mean, yeah, they got the table. I don't want to use the table. I'm going to go over here, and instead of normal, we go to student. I'm going to write that down. Go to student. And we put in what we got. So my degrees of freedom here is 17. And then I'm looking for 0.005. And you can see that's really tiny. And it's on the left. Does it match my picture? Cool. So what was like that cutoff line? Negative 2.8982. You round to whatever you need to do, of course. And there it is. We can, and like, just like, let's go back up to the table for a second. If I went to the 17, is there a 2.898? Yeah, there it is. 2.898. There it is. Could I have used the table to get there? I guess. I mean, it's not that hard. But what if you don't have a table? What if they somehow, they'll always have a table. But what if? Okay. Two-tail tests. How wonderful. Okay. They say that both of these are 2%. Both. So then what would each of them get? 1%. I don't want to use alpha. I'm just going to say 1% each. Awesome. Degrees of freedom would be what? 21. And I am doing the one-sided thing because I know that GeoGebra doesn't let me do the two-sided thing. Again, if you went back over here and tried to do this kind of thing, you can't click on anything over there. So that's why I'm trying to stick to this. Negative 2.5176. Yeah, it's round to whatever they say. And finally, hopefully we'll never have to do this again. Except for on your homework, then you have to do it again. Sorry. Am I just mean or something? Thank you. Thank you. Yes. Degrees of freedom is? Cool. 19. I'm going to go on this side this time. Change it to the 10%. And I got 1.3277. Awesome. There it is. Good. Any questions? Okay. Y'all are easy to please. Except that y'all want me to let y'all out. I know. Here, like we had talked right before, we have this day today, and then we have Thursday, and then I want to review next week. And I'm guessing you might want me to review maybe more than one day. So I'm trying to prepare ahead of time for that. If we do not do any other math, well, then I'd have only the 2 days whenever we come back for both 9 and 12, and that's tough. So the further we get today, the further we can get next time, the more review we can get. But I'm gonna finish 9 before Thanksgiving. Okay, that way we're done with it for sure. So that I don't want it to take away from our review time. All right, so blah blah blah. We've already seen all this. See, they have the n greater than 30 also. All right, so an insurance agent says, that's the claim, that the mean cost of insuring is more than this much. Okay, already I can start setting it up. If you're bored, that means that you know stuff. So that's good. I know. Okay, what would I put right here? Greater than. So up here it's perfect. Tail test. I just mixed it up. Did you see that? It should be this way, greater than. You say greater than, and I was like, oh, less than. Okay, I should not. First off, you should watch me, because I'm going to make mistakes. But second off, I should still take it seriously. Every question is equally important. Yeah. Okay. Again, t-test of a mean. So that one's easy. That's the 1350, and I'm going to go greater than. So what's the mean that they found? 1290. This is odd. Standard deviation. Okay, n is 9. Now, this is odd. I already knew something was a little weird before I even got the numbers back. Look around for a second. Not more than 1350. Oh, it's definitely more than that. And then he goes around and asks 9 people, which is again a little weird, but he asked 9 people, and he got an average that's less than 1300. He says it's more. He didn't even get more, but like, you know what I mean? It's so weird. Yes, yes. So it is a weird thing, like already. Like at this point, just between you and me, if I didn't get more than that, I would just stop. Like, we're done here. I don't have to keep testing. But that's like even now, look, Chomp Chomp the bigger one. That's like a guaranteed fail to reject. Again, that's except H naught. So I accept the original H naught. I definitely couldn't prove against it. No way I can prove against it. In fact, this statement is saying that it's less than 1300, and that's what I got. I mean, we're stating the original status quo. So yeah, that's the good one right there. So this is bad. Again, that was my claim. I forgot to write claim. Claim is bad. Bad claim. So yes or no support for the claim. No support for the claim. And there we go. It doesn't even look like English anymore. It just looks like scribble. But I mean, we've done it like a bazillion times, right? Is this okay? GeoGebra. Well, yay. Let's look ahead. So, okay, we got this one. Oh, it says use the p-value. Oh, no, really? Like, we've been doing that. But, okay, so what it scares me, actually. Okay, I'm sorry. Let me get scared for a second. Let's say that they asked us to do the critical, the rejection region. And so let's just say that I got an alpha of 0.01, and they want to know where's that cutoff line between the two. Okay, so then I'm doing this the long way. Don't want to do it. What would be my degrees of freedom? 8. That's odd, isn't it? I want to be on the right side, and my alpha was 1%. And so that cutoff line is at 2.8965. Okay, so that's my cutoff line right there. So far, so good. Again, this is stuff that I don't want to have to do, but sometimes they'll force us to. If we go back, ours was negative 2.57. So that's like over here, negative 2.57. Am I inside the rejection region? No. Fail to reject. Just in case they ask. I know that the homework will occasionally ask. Where you scroll the line over. Good? Okay. I just wanted to verify on that, okay? So let me keep going. So we got this guy. They say to use p-value, which we do all the time anyways. Doesn't really matter. We got another one, and then we're done with that. So I think we can. I don't know if we'll finish, but I think we can at least get done with 1 or 2 more. I mean, we've technically got 1, 2, 3 more questions. Only 3, and we've done this like so many times. Let's keep rolling. Company claims. Pause. No, I'm just joking. We got to keep going. Is different than that much. So then we got a mean. We got the 1890. 1890. It says different is not equal to versus equal to. This is my claim down over here. I should probably have just written that a little bit better. And this is going to be a this will be the last one I'm going to do with the rejection region stuff. But I just want to test it again, just in case, you know. Okay, so, yep, two-tail test, claim, high. Good. Okay, yeah, so I guess that was it for that one. Keep going back. So we got the 1890. So conducted a water sample dissolved in this. We got 19 folks. Notice that this is N. It's just 19. We don't have to minus 1 or nothing, okay? Just N. What is my standard deviation? 700, mean of 2,500, and they're saying alpha is 1%. So P alpha 0.0007. Oh my gosh. So it was 1890, and we're saying it's different. We got 2,500. Wow. This looks different to me. And I know that we only did 19, but that's pretty different from the average of 19 of them, okay? So chomp the bigger one. So P is less than or equal to alpha. We reject H naught finally. Haven't done that in a while. So then I'm going to reject H naught. Claim is good. And so then I'm going to have yes or no support for the claim. Oh. Thank you. That's true. But thank you for telling me, because they will ask. They're going to say, hey, what's the p-value? And I get it wrong. Why? Right? So that was my bad. My bad. You're right. But thankfully, everything else is still the same. Yes or no support for the claim? Yes, support for the claim. All right, cool. Now, I'm going to do this rejection region thing just to make sure that we're all okay, but I'll never do it again. So it's a two-tailed test, and I need to figure out what's going on. They say that alpha is the 0.01 for both, and therefore for each would be how much? Exactly, 0.005 each. So let me go back over here. Degrees of freedom, what would I put for this one now? 18, always 1 minus the 19 there, 1 minus the n. And you could do left or right side, it don't really matter. So we're doing a 0.005 for each. Oops. And so then I got this right here is at 2.87, and this here is at negative 2.87. There it is. Awesome. Okay, here's what I'm thinking. We'll do one more, and then we'll, maybe I got to do 2 more. No, I meant like, there's no way we can do 2 more. Let me look ahead just real quick. Hold on. Just looking ahead. Oh, that one's a really short one. Okay, let's call it here. That way we can come back and review this next time. Is that cool? Okay, we're good, because I know we're kind of pushing time all of a sudden. So thank you, guys. Y'all have a great day, and I'll see y'all next time.